Gnana Deeksha, Concept-Based Digital Learning. I am K. Janaki, Mathematics JL, TSWRS, Shamshabad Boys College. Today we are going to learn about Introduction to Complex Numbers. Right from childhood, we have been learning different kinds of number systems like natural numbers, whole numbers, rational numbers, irrational numbers, integers, real numbers, etc. So, what are these real numbers? Real numbers are those numbers which can be represented on a number line. So, if we take a line, these real numbers can be represented on a number line. So on. So, what are rational numbers? Rational numbers are those numbers which can be represented as ratio of two integers with no common factor. Say suppose we have a number 2, we can write it as 2 by 1, which is in the form of p by q, ratio of two integers. Say suppose we have 1.25, which is in decimal notation, can be written as 120 by 100, in its simplest form it is 5 by 4, a rational number. Or if we have 0.333 so on, which is a recurring decimal, can be written as 1 by 3, which is a rational number. So then, what are irrational numbers? Irrational numbers are those numbers which cannot be written as ratio of two integers. So, if we represent these irrational numbers in decimal notation, they are non-terminating and non-recurring decimals. So, these are rational numbers. Some examples, and irrational numbers will be like root 2. If we consider value of root 2, it is 1.4142 so on. It never ends and no number will be repeated. Say take the value of pi. Pi is 3.141592 so on. So such non-terminating, non-recurring decimals are called as irrational numbers. Apart from these number system, do you know any other kind of numbers? Just think. Is square of a number can be a negative number? Means if you multiply any number with the same number, can we get a negative number? Is it possible? Let us check some examples. Positive 3 into positive 3 is nothing but positive 9. Negative 5 into negative 5 is again positive 25. Minus into minus will become plus. Say negative root 3 into negative root 3 is nothing but negative into negative is positive. Root 3 whole square means again it is a positive number. So we can conclude that square of any number, whether it is negative or positive, our result will be always positive number. Now in quadratic equations, we have solved some equations like x square minus 9 equal to 0. If I solve this equation, x square is equal to 9, then x will be equal to plus or minus under root 9. Then what is x? It is plus or minus 3. While doing quadratic equation, the general form of a quadratic equation is ax square plus bx plus c equal to 0. For this quadratic equation, by using the formula x equal to minus b plus or minus under root b square minus 4ac by 2a, using this formula, we will be finding roots of the quadratic equation. So this b square minus 4ac is called discriminant. So, if this discriminant is negative number, we studied that the roots are not real, or we say that that particular quadratic equation does not have real roots. Let us consider the equation x square plus 1 equal to 0. If we compare this with ax square plus bx plus c equal to 0, convert in the same form. As there is no coefficient of x, it is 0 into x plus 1 equal to 0. So here value of a, that is coefficient of x square, is 1. B value is 0, coefficient of x is 0, and c value is 1. Let us calculate its discriminant. B square minus 4ac, that is 0 square minus 4 into 1 into 1, which is equal to negative 4. So as discriminant value is negative, we say that this particular equation does not have real roots. So if we solve the equation x square plus 1 equal to 0, take this plus 1 to right hand side, then this will become negative 1. Then x will be equal to plus or minus under root negative 1. As we said earlier, under root of negative numbers are not defined in real number system. So this particular equation does not have real roots. To overcome such problem or to solve such equation, in 16th century, an Italian mathematician, Cardan, tried to solve such type of equations which have negative discriminants. In 18th century, a mathematician Euler gave the value to under root negative 1 as I, which is called iota. I is iota and I is a unit imaginary number. So, under root negative 1 value is given as I, which is a unit imaginary number. Now, if I is under root negative 1, I into I is what? Under root negative 1 into under root negative 1. That is, I square is equal to under root negative 1 whole square, which is nothing but negative 1. So previously I asked a question, is square of any number can be negative? Yes. Square of I is negative number. I square is minus 1. So let us consider a number, say 7 plus 3i. So in this part 7 is called real part and this 3i is called imaginary part. Imaginary part. So this combination of real and imaginary part is called a complex number. So a complex number a plus ib, which is in the form of a plus ib denoted by z, is called a complex number which can be represented in the form of an ordered pair a comma b. Now let us see the pictorial representation of number system. We know that natural numbers denoted with n, or we can call them as counting numbers, are subset of whole numbers which includes a number 0, and these whole numbers are subset of integers which includes negative numbers. So in whole numbers 0 and in natural numbers 1, 2, 3 and so on. So in integers there will be negative number system, minus 1, minus 2, minus 3, so on. So these integers are subset of rational numbers which are in the form of p by q, that is we can express them as ratio of numbers, two integers with no common factor, and then irrationals, q dash. These are the numbers which we cannot denote in ratio of integers. Now, combining all these, we are having a number system that is called real number system R. A is some number, it may be a rational or irrational numbers. And we are having one more number system which is called purely imaginary number system. So combination of this real system and imaginary system, that is a plus ib, is called as complex number. Now, let us define a complex number. Complex number is an ordered pair of real numbers. So, C is defined as an ordered pair of A comma B, where A is a real number and B is also a real number, which is from cross product of R cross R. So, let us now discuss about equality of complex numbers. Say we are having two complex numbers. So, equality of complex numbers. Say we have two complex numbers. Z1 is equal to A plus IB. In ordered pair, it is A comma B. So, Z1 equal to A plus IB, which is equal to A comma B. Z2 is equal to C plus ID, which is equal to C comma D. If Z1 equal to Z2, when is it possible? Only when A will become equal to C and then B will become equal to D. That is, real part should be equal and imaginary part should be equal. Only then we say that the two complex numbers are equal. Suppose we have a complex number Z is equal to x plus 2y and Z1 is x plus 2y. Z2 is equal to 2 minus 3i. Z2 equal to 2 plus 2i. Then what is value of x? Since Z1 equal to Z2, I can say that real part should be equal. So x will become equal to 2. Now let us see addition of two complex numbers. Say I am having first complex number Z1 equal to A plus IB, which is equal to A comma B. Z2 equal to C plus ID, which is equal to C comma D. And I want to find sum of these two complex numbers. Then Z1 plus Z2 is equal to add two parts of real numbers. So that is A plus C plus I times add imaginary parts, that is B plus D. So whenever we want to add two complex numbers, we have to add real parts and then I times sum of imaginary parts. Now let us see negative of a complex number. So negative of a complex number. If Z equal to A plus IB is a complex number, Z equal to A plus IB is a complex number, then negative of Z is denoted by minus Z and it is given as minus of A plus IB, which is nothing but minus A minus IB. So negative of Z is nothing but we have to change sign of real part as well as imaginary part. Even we call this negative of complex number as additive inverse. Say if Z equal to 2 plus I is a complex number, then additive inverse of Z, that is minus Z, is given as minus 2 minus I. We have to change signs of both real and imaginary parts. Now let us see difference of complex numbers. Difference of complex numbers. If Z1 equal to A plus IB, which is denoted as A comma B, and Z2 equal to A minus IB, that is, C plus ID, that is C comma D, then difference of complex numbers Z1 minus Z2 is nothing but Z1 plus of minus Z2, that is addition of Z1 and negative of Z2 is given as A minus C plus I times B minus D, that is difference of real parts, then I times difference of imaginary parts. So this is called difference of complex numbers. So now let us see product of complex numbers. Product of complex numbers. If we have two complex numbers, say Z1 is equal to A plus IB, again A comma B, and Z2 is equal to C plus ID, which is given as C comma D, then product of Z1 and Z2 is given by Z1 into Z2 is equal to A plus IB into C plus ID. So, which is equal to, multiply this entire C plus ID with A first and then C plus ID with IB. So, A into C, AC plus A into IB is I times AD plus I into BC. I times BC plus IB into IB is I square times BD. So, which is equal to AC plus, if we take I common from these two terms, this is AD plus BC plus, we know very well that value of I square is -1 times BD. So, which is equal to AC, if I take this is minus BD, which is real part of product of Z1 and Z2 plus I times AD plus BC. So, we can remember product of Z1 and Z2 as Z1 into Z2 is equal to AC minus BD, comma AD plus BC. So, this is product of two complex numbers. Now, let us see conjugate of a complex number. So, what is conjugate of a complex number? Conjugate of a complex number. So, any number z equal to a plus ib, then its conjugate is denoted by z bar, and it is defined as a minus ib. Means only sign of imaginary part we have to change. So, conjugate of a plus ib is nothing but a minus ib. So, let us discuss about inverse of a complex number. So, inverse of a complex number. Inverse of a complex number. So, if z equal to a plus ib is a complex number, then its inverse of z denoted by z inverse, which is nothing but 1 by z, is given as a by a square plus b square, comma minus b by a square plus b square. Let us see how we got this. See, z is equal to a plus ib, then 1 by z will be equal to 1 by a plus ib. So, in order to eliminate complex number from denominator, what I do, I will multiply and divide with conjugate of complex number. So, conjugate of a plus ib is what? A minus ib. So, multiplying and dividing with conjugate of complex number, we get, so 1 into a minus ib is a minus ib divided by, if you observe the denominators, this is in the form of x plus y and x minus y. So, x plus y into x minus y is nothing but x square minus y square. So, a square minus ib whole square. So, which is equal to a minus ib divided by a square minus I square b square. So, which is again a minus ib divided by a square minus, we know very well that I square value is minus 1 into b square. So, it is a minus ib divided by minus into minus will become plus. So, if we split real and imaginary parts, we will get it as a square by a square plus b square plus I by minus b by a square plus b square. So, inverse of a complex number can be given as a by a square plus b square, comma, minus b by a square plus b square. Let us do some problems now. Find additive inverse of following complex numbers. So first one is minus 6 comma 5 plus 10 comma minus 4. Second one is 1 comma minus 2 into 0 comma minus 1. So here we are having two problems and we have to find additive inverse of the two problems. Let us take first one. We have to find additive inverse of minus 6 comma 5 plus 10 comma minus 4. Means addition of two complex numbers. So let us add first real parts, that is minus 6 plus 10 comma, then add imaginary parts. So 5 plus of minus 4. So here we will get it as minus 6 plus 4 plus 10 is 4 comma 5 minus 4 is 1. So our complex number is 4 plus I. So additive inverse will be additive inverse of 4 comma 1 is nothing but minus 4 minus I. We have to change signs of both real and imaginary parts. So this is minus 4 comma minus 1. Now let us see second problem. Find additive inverse of 1 comma minus 2 and 0 comma minus 1. So it is 1 minus 2i times 0 minus I. So 1 into 0, 0. 1 into minus I, minus I. 2i into 0 is 0. Minus into minus plus 2 times I square. So this is minus I plus 2 times I square is nothing but minus 1. So it is minus I minus 2. So our complex number is minus 2 minus I. So additive inverse will be this. We have to change signs of both real and real and imaginary parts. So this will be 2 plus I. Now let us discuss one more problem. Let z is equal to cos theta, comma sin theta. Then we have to find z minus 1 by z. So 1 by z is nothing but multiplicative inverse of given complex number z. So given z is equal to cos theta, comma sin theta. That is cos theta plus I sin theta. Then what will be 1 by z? 1 by z will be equal to 1 by cos theta plus I sin theta. In order to eliminate complex number from denominator, let us multiply and divide the fraction with conjugate of denominator. That is 1 by z is equal to 1 by cos theta plus I sin theta into cos theta minus I sin theta divided by cos theta minus I sin theta. So multiply numerators. So 1 by z is equal to 1 into cos theta minus I sin theta is nothing but cos theta minus I sin theta by, if you observe the denominators, it is in the form of a plus b into a minus b. So it is a square minus b square. So cos theta whole square minus I sin theta whole square. So 1 by z equal to, write numerator as it is, 1 cos theta minus I sin theta divided by, this will be cos square theta minus I square sin square theta. So 1 by z is equal to cos theta minus I sin theta divided by cos square theta minus, we know very well I square value is what? Minus 1 sin square theta. So what is 1 by z value? It is cos theta minus I sin theta by cos square theta minus into minus plus sin square theta. So we know very well that value of cos square theta plus sin square theta is 1. So 1 by z is equal to cos theta minus I sin theta divided by 1, which is nothing but cos theta minus I sin theta. Now let us calculate the value of z minus 1 by z. So z minus 1 by z will be equal to value of z is cos theta plus I sin theta minus cos theta minus I sin theta. So this is cos theta plus I sin theta minus cos theta minus into minus plus I sin theta. We can cancel positive and negative cos thetas. So it is 2i sin theta. So here there is no real part. We are getting only imaginary part. So it is a purely imaginary complex number. So z minus 1 by z can be given as 0, 2i sin theta. Next, do one more problem. Find multiplicative inverse of 7, 24. So we have to find multiplicative inverse of 7, 24. We already discussed that multiplicative inverse of a comma b is, it is given by a square plus b square comma minus b by a square plus b square. So here what is your a? A is given as 7 and b is given as 24. So we can write its multiplicative inverse as, so multiplicative inverse is equal to 7 by 7 square plus 24 square comma minus 24 by 7 square plus 24 square, which is equal to 7 by 7 square is 49, 24 square is 576 and it is minus 24 by 49 plus 576. So which is equal to 7 by 625 comma minus 24 by 625. So we can write the inverse of complex number of, so inverse of 7 plus 24i is given as 7 by 625 plus I times minus 24 by 625. Thank you for giving me this opportunity to participate in Gnana Deeksha. Thank you.